Hello, everybody. Welcome to Druid 2030. So we'll see how well we can predict the future, but we'll start with a voyage into the past. So let me start with the required disclaimer. I am a member of the Druid community giving my own thoughts and opinions. What I say does not speak for the entire Druid community, nor for Imply data, nor for my wife, nor for my cat, nor for my children, nor anyone else but me. So if I say anything that you find offensive or incorrect, feel free to throw objects at me, but do not blame the Druid community or Imply. And of course, thank you for the Real-Time Analytics Summit organizers for inviting me and Imply to participate. You know, Pinot and Druid are open source cousins. And while Imply competes with StarTree, Pinot and Druid are all part of this open source world. We regularly advance together as real-time analytics comes up for everyone. All right, now I don't have to say any more nice things about Pinot. I was also told by my boss that I had to say something about me. So that's a picture done by a friend of my wife that shows some of my interests in it. After Georgia Tech, I worked for the United Nations, then ended up working for the US Congress, then spent some time at NASA, where I started as a physicist and somehow ended up running IT operations at Johnson Space Center, and have spent the 35 years since then working in IT and databases. At NASA, they gave me the nickname of Dr. Heat Death, because I was known for putting in queries that would not complete until the heat death of the universe, so some of those queries may still be running, I don't know. In any case, I spent a long time at IBM, retired, went to Couchbase, went to AWS, went to Snowflake, and at the beginning of last year joined Imply because I'm excited about real-time analytics. And then I'll say just a few words about Imply, and then everything else today will be about the open source. So Imply was founded by the creators of Apache Druid, not to make money, not that they're against making money, but really it was about how do we make Druid more accessible and make it so more people can use it and get benefit out of it. So Imply provides support, Imply provides a commercial distribution, and our fastest growing product at Imply is Polaris, which is a cloud database as a service. So if you've never played with Druid and you want to play with Druid, the easiest way to do that is go to imply.io and click on Get Polaris, and there's a 30-day free trial. Doesn't even need a credit card, just an email address. So a nice way to play with this stuff if you want to see it. All right. So before we talk about the future, let's talk about the past and the present. So Druid is very different from how it began. So in 2010, there were some engineers at a ad tech company. And they had a problem. They needed to be able to ingest 1 billion objects in under a minute and query those 1 billion objects in under a second. So they tried doing it with Postgres and various other relational technologies. It didn't work. They tried it with Elasticsearch. Didn't work. They tried some NoSQL things and Hive. It didn't work. So they said, well, we'll just write our own database. How hard can it be? Okay, it turned out it's kind of hard. And some of these people told me, we were in our 20s and we were young and stupid. If we were in our 30s, we would have gone, no way am I going to try to write my own database. But fortunately for the world, they were young and stupid, and they built a really good database off of different prospects, which is Druid. Druid became an Apache top-level project quite a while ago. Imply was founded in 2015. We're seeing a lot of things advance. I'll talk about some of the things coming around, things like Shuffle Mesh and multi-stage query engine, and then a little bit about what we think is coming in the future. So in the beginning, this is a blog post that was published on April 30th, 2011. So we're right now right about the 12th anniversary of Druid being released to the world. Mentioned it was from AdTech. Tried and failed with a bunch of other things, announced a Druid, woohoo, it works. And then, because they were not a database company, they were an ad tech company, so they said, how do we get other people to work on this project without having to pay them? Oh yeah, we open source it. Like so many things became open sourced. And the first company that looked at this open source thing says, that's really cool, I'm going to use this. And it's interesting because at the same meeting, which happened in San Jose, was Netflix and a bunch of people from LinkedIn who had written this thing called Kafka, and the Druid people. And the Netflix people said, ooh, I like both of those. And they put them together and started using it. Netflix, as you may be aware, is still a very large user of Kafka and a very large user of Druid. Went to an Apache license in 2015, went top level in 2017. Today there's over 1,900 organizations that are running on Druid. Like anything else open source, we don't really know the number. I know how many are paying Imply, it's less than 1,900, but there are many organizations using Druid. And one of the fun things about being at Imply is every week we have someone we had no idea that was using Druid who comes to us and say, hey, I could use a little help with the Druid. So, the joy of being in the open source world. It's also a pretty big community that's grown up. So there's at least 14,000 people who are community members. And we're defining community members as somebody who has done something active in the community in the last 6 months. So that means in the last 6 months, they either put a message on Druid Slack, or they attended a meetup, or they made a contribution to Druid, or did something active that we can measure. So it's a pretty good sized community. Druid, the next release of Druid, which is Druid 26, is currently in code freeze, targeted to release the week of May 15. If you know anything about how the Apache Software Foundation works, you get a release candidate, and then you have to have a 2/3 vote by the project management committee. So that release candidate is probably going to come out next week. So might be the week after. We'll see how it comes together. So we have about 700 people who made contributions into this release of Druid. And we're getting a release coming out about once a quarter going forward. So it said 1,900 organizations. Community is increasing about 150% a year. So we're certainly seeing this grow and a lot of people using it and interested in it. All right, enough boasting. What is Druid right now? Well, I don't think anybody at this conference needs to have explained to them what a real-time analytics database is. Anyone here doesn't know what real-time analytics is? Yeah, it's good. I'm the only one with my hand up. I'm still trying to figure it out myself. Yeah, there's a few people back there. There's one guy going, yeah, I don't know. Here's how we see it, because this is what our customers are telling us that they need and they require. So one is sub-second queries at any scale, right? It's not just scale. It's not just having terabytes and petabytes. All sorts of data analytics technologies can do petabytes. I can put a petabyte in a Snowflake, or easily put a petabyte into various data lakes. But none of those data lakes are going to give me a sub-second response on a query. So the first thing is I'm dealing with very large amounts of data, typically, and I need to deal with them quickly. The thing I'm showing on the right, okay, I'm cheating, that's an animated GIF, but it's taken from real analytics, is doing interactive conversations with data, right? Coming in, zooming in, whatever. If I showed you what's under that, each time, like what you just saw, it kind of zoom in and pop there, that's about 30 SQL queries. Each of those 30 SQL queries have to complete in no more than about 200 milliseconds for this to be working at this speed, right? So what if I was trying to do this kind of thing on something like Snowflake? And don't get me wrong, Snowflake is great for what it is. It's a great reporting database. But queries in Snowflake don't happen sub-second. The fastest you're going to get is like 6 to 10 seconds, and some will take minutes. So if I'm doing something like that, it's kind of click, go get some coffee. Come back, go get some cream for the coffee. Maybe the screen will be up. Second thing, high concurrency. This is a big deal. In fact, you heard Kishore mention at the keynote, if you heard it this morning. This is one of the things that real-time databases have in common. I'll pick on Snowflake a little bit again. Right? Snowflake is probably the highest concurrency you can get in data warehouses. So one Snowflake virtual data warehouse can run 8 concurrent queries, and Snowflake can scale up to a cluster of 10, so that can run 80 concurrent queries. Our customers are running hundreds of queries per second, thousands, tens of thousands. So 80 isn't going to cut it. Now, technically, any database can be highly concurrent if you throw enough hardware at it, right? I can always say, oh, I'll just set up another Snowflake cluster and another Snowflake cluster and another Snowflake cluster, or Databricks cluster, or whatever. But you need that to be cost effective. So real-time analytics almost always has a high concurrency requirement. Third one is combining not just the real-time stuff, but history as well. There are a lot of stream processors that can give you a query on what's happening now. Anybody ever use like KSQL in Kafka? Which is good for what it does. It lets you query a stream as if it was a SQL object. Problem is, that only tells you what's happening right now in that stream. In real life, I not only need to know what's happening now, I need to put it in context. What happened a minute ago? What happened an hour ago? What happened last year? What happened last time a hurricane hit this part of the country? So I can compare that data. So almost every time we see someone doing real-time analytics, it's at least 2, and often all 3, of those requirements. And frankly, if you don't need those things, there's other technologies that will let you get the job done cheaper. The little star there is usually not an upfront requirement, but some people realize pretty quickly, which is I also need my real-time analytics database to not go down. If I'm running a typical data warehouse and like I'm running a daily sales report, so it runs at 2 a.m. every day, and it goes down for an hour, nobody cares. As long as it comes back up and you get the report. But if I'm doing real-time analytics with streams coming in real time, it goes down, I got a problem. So you have to have a real-time analytics database has to be something that doesn't go down. Now, of course, Druid was designed for all of these, and in the Druid design, there's 0 planned downtime. Everything is automatically backed up into what we call deep storage. Not a terribly different concept than Pinot and others use. So you're not going to lose data unless you lose your entire deep storage layer, which when you're on the cloud, of course, is widely distributed. And you're not going to lose throughput unless you lose all your nodes. So I could run Druid on a laptop. OK, then if the laptop goes down, the Druid goes down. But if I'm running it on 2 laptops or 2 servers, I have to lose them both. If I lose one, I'll lose some of my throughput. So we have people running Druid on one machine. We got people, the biggest cluster I know of on Druid has 45,000 nodes. So 45,000 servers, and those are each, by the way, 4-socket servers that each have 16 CPUs. So that's a fairly large cluster. And we have everything in between. And of course, I can add and remove without any downtime. So when a node fails, there's no failover, that's just damage. Druid works around it. It lost that much capacity. When you add another node, it adds it. And this is reinforcing what I said earlier. If I'm using a real-time analytics database, I get something like what's shown on the right. And if I'm using some other technology, I get something like what's shown on the left. And we've all lived in that world. So Druid is built for this intersection of analytics and applications. So here's another way of looking at this, because if you look at most of the databases in the world, they're either transactional databases that are aimed at applications, or they're analytics databases that are aimed at data analytics. And of course, they have a range of requirements in them. So if I look at transactional databases, they're designed to write small data quickly with ACID integrity, but work really fast, sub-second, a lot of concurrency with real-time data. Take data in with streams or a lot of stuff hitting it. Well, if I look at the data warehouse world, that's mostly for business intelligence reporting, mostly for static dashboards or things that don't change that much, read optimized, big data, often high cardinality, and asking complicated questions. Right? So in the applications world, when I'm doing a query, it's a query like, what's the status of order ABC 107? And in the data warehouse world, when I'm asking a query, it's something like, what are my 50 most profitable products, and how has that changed each of the last 52 weeks? And if you think about that, that's a more complex query than it sounds like, because how do you figure out what's profitable? Now I have to know what I sold it for, how much it cost me to build it, how much it cost me to sell it, how much tax I paid on it, what it cost me to ship it. These become complex things. Well, real-time analytics is about half of each of those categories. Because when we look at what we do in real-time analytics, we're not focused on ACID and that level of integrity, because it's not the sole source of truth. And we're not doing the static stuff. But we are doing large amounts of data, often of high cardinality. We are read optimized, but still need sub-second response, the high currency, and the real-time data. So this really is a third category. And I put this slide together after having way too many conversations with people from places like Gartner or Forrester who kept asking me, so are you analytics or transactions? I couldn't quite get this as kind of a third dimension. I have to admit that in the last year, I haven't had most of those conversations. The people in the analyst community, at least, are starting to get it and see what's happening with real-time analytics. For that matter, if we had a real-time analytics summit, say 4 years ago, it would consist of Druid and kind of nobody else. But today, I've got Pinot, I've got Star Rocks, I've got other things if you walk down our exhibit hall who are out there doing these things. All right. So who's actually using this stuff? In this room, I probably didn't need to go through this, but I'll mention some of the ones who do it with Druid. So these are the 4 use cases that drive most of the Druid out there. So a big one is operational visibility at scale. So sometimes that's organizations that have built observability platforms that are using Druid to power it. So Thousand Eyes, which is now part of Cisco, Splunk, a whole bunch of others I could name, who are using Druid as the engine that lets them do big observability. But others are customers who have such big needs they can't use anything out of the box. So one example there is ICE, Intercontinental Exchange, which operates in New York Stock Exchange. As you might imagine, the New York Stock Exchange attracts a lot of malicious actors. You know, when you're trading, $3 trillion a day, that tends to make people want to find ways to take some of that stream of money. So what they're using the Druid for is to monitor all of the network operations and be able to find in sub-second the anomalies that have come up and then be able to act on them in sub-seconds. So in the old days, before they turned this system on in 2020, 2021, on average, they had to stop trading 2 or 3 times a year because they had network issues and they couldn't guarantee the integrity of the market. They have more attacks now than they used to, especially the last 6 months. But they haven't had to shut down the market once because we're now able to detect and act on those anomalies sub-second. Customer-facing analytics is another big use of Druid because of that high concurrency. If you're someone like Citrix, if you're someone like Atlassian, anybody here use Atlassian? Everyone who's a developer, raise your hand. I know you're using Atlassian to some degree. If you go into Confluence or Jira and you hit the button that says Analyze, so it gives you all the stats, guess what? That's Druid underneath. Now, if you're Atlassian, how many customers are going to hit that Analyze button in the next second? You don't know. Could be 0, could be 6, could be 60,000. So you got to make sure you have something that can handle that concurrency because you don't know. I mentioned Thousand Eyes, another good example, which is, they don't know how many people are going to run queries. Thousand Eyes started on Mongo. MongoDB is great for development. It was great for their first year. It was okay for their second year. Third year, they had too many customers and it wasn't working. The latency was too long and the concurrency wasn't high enough. And this is a big part of real-time analytics, right? We're all in this world of the right tool for the job. And the right tool in 2019 might not be the right tool in 2023, right? Because things change and requirements change. So we see a lot of that where people start in other places and move to Druid or other real-time analytics. Rapid data exploration is another interesting one. Salesforce is pulling in every day 40 terabytes roughly of data. So it's not real time for what they're doing. They're actually not delivering in streams or batching it in about once an hour. But they need to do that interactive exploration across it. So mostly that's for their own operations, just to figure out what's happening in their 150,000 customers and being able to do operational excellence. But they're also starting to expose that to their partners. And then the last one, which is kind of fun, is real-time decisioning, when I need to make decisions really fast. This gets back to the ad tech that we started with. How much time do I have when you pull up a web page to figure out what ad to put in front of you that I think you'll click on? The average is 300 milliseconds. So you have people who place a lot of ads like Reddit. And here's the thing, we all know this as internet users. Do you ever click on an ad that you see? Not much, but you're definitely not going to click on it if it's not relevant to you, right? There was a period, I'm not sure why, I'm Jewish, and Safeway Corporation really wanted to sell me bacon. It's like anywhere I went online, there was like this ad for better and better price on bacon. I actually told my rabbi about this, and he said, if the price is that good, you should buy it and donate it to the homeless shelter. So I learned 2 things. 1, the ads are not that relevant, and 2, don't ask your rabbi for advice, because it's always going to involve you spending money on something. But that being said, Reddit is using this for real-time decision-making. So when you pull up a subreddit, do they know enough about you to put an ad in front of you that's actually something you'd be interested in and something you might want to click on? I'm not going to click on the bacon ad. On the other hand, I could use a new USB dongle for my Mac here. If somebody put that in front of me, I might click on that ad. And those kind of things happen. So if we drive a little deeper into this, what makes Druid different? So if I compare Druid to other real-time analytics databases, let's make it clear. Druid and Pinot are like 95% identical, right? They're mostly the same use cases, they're mostly a similar architecture, they're mostly trying to do the same things. So here at this conference already, I've had about 20 people ask me, how is Druid different than Pinot? And the answer is it's not that different. It's a little bit like comparing, say, a Toyota to a Volkswagen, right? They're doing the same thing. Okay, one has more cup holders, one has a nicer back seat, but they're similar. Here's the small places where the 5% are different. The biggest one technically is storage segmentation. Druid has its own model for creating and writing segments. It doesn't use Apache Helix. It doesn't use any data lake technology like many others do. It is something that was written explicitly for Druid. Every single piece of data gets indexed. Ingestion in Druid means indexing. We don't have a whole bunch of different indexes because we don't need a whole bunch of different indexes. Everything gets a list index, everything gets an inverse bitmap index, and everything that's a string field gets a dictionary encoding. This lets us get consistent high performance with every use case that we run in here. So compared to something like Pinot, less management of indices, but also less flexibility, right? Pinot gives you a lot of index flexibility when you're using it. Maturity. So here I'm, picking a little bit on, say data warehousing, which is kind of hitting its level of maturity, where something like Druid and real-time analytics is still up there. But Druid is just more mature than any other real-time analytics databases. That's mostly a plus. It just means there's more people using it, more experience, larger community, other pieces. Still plenty of room for other stuff, which gets down to scale. We have lots of customers out there with tens and a few with hundreds of petabytes. It's not an uncommon thing. We also have lots of customers with gigabytes. So everything, a whole range works in there. I keep saying customers. For open source, I should say users. But it's all there. I've never liked calling things users, right? Because there's only two industries that call their people users. The other one's illegal drugs. And I just never liked that term. But whatever you want to call the community, there's some big scale. Some of the ones I can't talk about are in the intelligence community. But there are some interesting groups in US, UK, and other intelligence that are using Druid for very large data collection analytics. I spent part of my career in the intelligence community. There's something there called the 30-second problem, which is somewhere in the world there was a big boom. You got about 30 seconds before the White House is on the phone saying, are we at war or was that an earthquake? You need a better answer than, I don't know. So that's the kind of thing that they do with Druid in the intelligence world, is what's happening in the world. Figure it out quickly. And then finally, community success, because I believe it's an absolute requirement for anyone who works in this industry to have at least one slide with like 24 customer logos on it. So there's my 24 customer logo slides. A little more than that, I think. Those are just some of the ones to mention. I mean, we could list, I'm not going to put 1,900 logos on a slide. But there's a whole bunch. Many are in tech, many are not in tech. Which is an interesting part of our fastest, we got a lot of tech customers, but our fastest growth are in people who are not in the tech space, who are in the intelligence space, in the defense space, in financial services, and in other places. So that maturity slide is hard to read, so here's a bigger version of it. And that 24 logos is hard to read, so here's a bigger version of that, and dividing it down into some of the different fields that we see people in. And this was just a almost random set that I grabbed for a few interesting ones. There's many, many others. All right. Time for the future. So first, the near-term future. In about 2 weeks, as I mentioned, next version of Druid, Druid 26. 3 big things coming in Druid 26. One of them I'll drill a little more into that I'm kind of excited about, which is schema auto-discovery, which is a fancy way of saying when I pull in my stream, or maybe pull in my batch file, it will find and detect the schema for me. And if that changes over time, it will automatically adjust the schema of the table. Shuffle joints. Now, if you've been paying attention to Pinot, you're familiar with this. One of the many ways our two communities are similar is the previous November, November of 21, the Druid community announced that our next big set of features are all built around a multi-stage query engine. Everyone says, that's cool. And then about 5 months later, the Pinot community announced our next set of features is based around a multi-stage query engine. Because we're all trying to solve the same problems. Now, one of the things I found interesting is that the order that the Druid community chose to implement MSQ and the order that the Pinot community chose to implement MSQ are quite different. So things that Druid are doing at the end of our chain, like cold storage, were things that Pinot did at the beginning of their chain. But if I look at the 2023 roadmaps for both communities, they kind of end up in the same place in December, at least around things like multi-stage query. But one of the things that Druid already has, and it will officially be part of the product in 2 weeks, is shuffle joins on ingestion and being able to do some cool things with data ingestion. And the other one is just adding more SQL stuff, unnest, arrays, window functions, some other things that were not completely present. There's also some cool stuff like sessionization, interpolation, advanced dictionary compression. I'll mention a few of those. So the schema auto-discovery, this is one of those interesting things in databases. Most databases are strongly typed, right? So if I go into, say, MySQL or Postgres, before you can put any data in, what do you have to do first? Create a table. And what do you have to do for every column in that table? Give it a name and a data type. And what happens if you later try to load data into that table and the type doesn't match? Right? You throw an error. That leads to the question of what happens if you forget to turn off your phone before you go on the stage. There. On the other hand, you have the world of schemaless databases. Anybody here ever play with something like, say, MongoDB or Cassandra? Where those have no typing, right? Indeed, every row in the database can be a different set of fields. The downside of that is it's really slow for analytic queries, right? If I'm trying to do a sum function across Mongo, it is slow. Now, they've changed some things in Mongo to make that a little better. It's still not nearly as fast as something like an analytics database. The cool thing about Druid now is I can do both of those. So I can turn off the flexibility and say whatever the table is created at, that's what it must always be. The database is right, throw out data that doesn't match. Or I can turn on the flexibility and say the data is always right. If the database doesn't match, change the database. So I'm doing something and I add a new column. Now, what does that actually mean? So let's say I have this use case where this is a real world case, that I have a voice assistant and I'm getting data streaming in. And so I've got a bunch of fields that are coming in for each event on the voice assistant. And then that's going into my analytics database, and analysts are using it. And then I start saying, those the new version of that voice assistant has a temperature and humidity sensor in it. So now we're going to start reporting temperature and humidity. Well, in the Druid world, the stream now has 2 extra fields in it. OK, I'll just add 2 extra columns, temperature, which will probably be a long, and humidity, which will probably also be a long. It'll auto-detect those. So what happens to all the entries that I had before that didn't have temperature and humidity? I'll populate them with nulls. And then, of course, I can go back and fix that if I have. In this case, I probably won't have data to fix that. The idea is I never break the schema, if this is the way I choose to run it. We also have the idea of joining. Now, Druid has had joins in Druid for a long time. And they've always been broadcast joins, which means it's a good way to join a dimension table with a fact table. And in a modern world where I'm running nodes with 30 plus gig of memory and the Java heap, my dimension table can be 20, 25 gig. So it can be a few million rows. But if I have a billion rows and a billion rows, that's not going to work. So we're now doing the shuffle joins. So before the shuffle joins, I usually had to use another tool to do the joining, which is true of most real-time analytics databases. So might be Spark, might be Presto, might be Flink. I could have put a lot of logos up there. But now in Druid, I don't need that for the joins. I can join tables of any size. So I can do that as part of ingestion, pulling it in. And one of the things that Druid has had for a while that makes it a little different than most real-time analytics databases is also the ingestion is SQL-based. I can still do a big ingestion spec in JSON, but mostly we only support that for legacy reasons. Most people using Druid now are going to use a SQL insert into statement in order to do all of the loading. And now we can do it with the joins, which makes it a little better. And as I mentioned, we're adding a nest, we're adding some more array stuff, we're adding some window functions. We're also doing sample by, which is kind of cool. So this is an actual example from our friends at Walmart, who interestingly, one part of Walmart's a big Pinot user, another part of Walmart's a big Druid user. But Walmart gets about 1 to 2 billion transactions a month. And let's say I want to do what's the actual average basket size with and without groceries, how is it trending over the last 18 months? Doing that over all billion entries is kind of too much work, because especially over all that time element. But what we learned from statistics is I can sample that. So there is a sessionization feature now in Druid that lets it query a subset and say, I only want to look at, say, 50,000 of those billion. And Druid will automatically not just grab the first 50,000, but statistically spread it out to make sure that I get a statistically accurate session. So that's really useful for doing a lot of these complex things and being able to do them fast. We can also automatically do time-weighted averages and interpolation. So look at a data set and figure out day parts. Looking at this data set, when is the store open and when is the store closed? Or, you know, an interesting thing they did at Starbucks is figuring out when's the morning rush, when's the afternoon lull, when's the evening rush, when's the store closed. And can you tell other events? Like Starbucks that are close to stadiums tend to get little peaks that other Starbucks don't get. Or when do the hurricanes start and stop? And figure that out automatically from the data sets. So it could be start, end of impactful events. It could be day parts. Just some useful stuff to do automatically. So that's interpolation. Now, finally mentioned, we came up with a new algorithm for compressing those string dictionaries even further. So we're getting about a 30% reduction in storage with it doesn't make it any faster, but it doesn't make it any slower either. So it just lets us be that much more efficient in storing things. And the cool thing is, you don't have to do anything. Just upgrade to this version of Druid and it's there. All right, later this year. Well, the big one is async queries. So we're doing async queries for ingestion. We're going to do it for query in probably Druid 27, which is, I'm sorry, yeah, 26 coming. So I lose track of the numbers. But Druid, so probably this summer, late summer, where we are able to do combining the scatter gather, because the bottom level of the mesh is actually scatter gather, with a mesh. So in Druid today, really big queries time out. Something that takes more than 30 seconds is probably going to time out. When I first joined Druid, there was this marketing thing of every query completes in 30 seconds or less. It's technically true because it fails if it doesn't complete in 30 seconds. That's not a good way to do it. With the async world and shuffle mesh, if it doesn't complete in 30 seconds, it gives you an update. It says, I'm still working and I'm 3.4% done. Or maybe I'm still working and I'm 0.0000001% done, in which case you probably want to kill that query and reconsider what you're asking. But you can have that level of control. And of course, what we've been waiting for async query for, because that's what we're going to use to power a really performance-effective way of doing cold storage. So some other real-time analytics databases have put a cold storage option, but if you look at the performance, the cold storage is 50 times slower than the standard. In the Druid world, the cold storage will be slower, but it'll be a much lower multiple. It will be much closer in the performance to the standard storage where the data is stored on the nodes. Further in the future. All right, I don't think I have to convince anybody here that streams are going to be everywhere, right? Right? Okay, move your head vertically for a yes answer. Move your head horizontally for a no answer. Everybody here believes that streams are going to be everywhere, right? They're not everywhere yet, but it's growing at a, okay, the guy from Confluent's doing this. But yes, the stream, ow, just hurt my head. These are numbers that are coming from Gartner. Last year, about a $60 billion addressable market, and growing at 19% a year. That's a crazy growth rate. That means it doubles every 3 years, right? And we're seeing this, and that's just people actually paying for it. That doesn't count all the people who are downloading and using open source Kafka. So we're seeing this grow like crazy. More streaming, more real-time data. Where did I get this number from? I don't have the source on the slide. It came to me through Tomo. Oh, there we go. IDC is where this one came from. Is that if you look at the data today, according to IDC, about 20% of all of the structured data is real-time. Now, I'm saying structured data because I'm not counting MRI scans, I'm not counting email, I'm not counting TikTok videos, right? I'm counting the stuff you would actually put in a database. But of that data, about 20% is real-time now, 30% in a couple of years, as the data grows at a very high rate. I'm sure we've all seen slides about how quickly global data is growing. Admittedly, a lot of that is medical and video. A lot of it isn't. Right? It's all the other things we're doing and keeping. Further out, one slide to talk about hardware. Some of you may have heard of this, some not. CXL is Compute Express Link. It is a new way to connect memory to processors. As you probably know, if you ever play with hardware, you almost never run out of processing power in a database. You run out of memory. You end up having to pay for more processors than you really wanted, simply to support the memory. And so when you look at database servers, the memory will be like 90 to 100% consumed, and the processors are running at like 20%, 25%. Because you put all these processors in there to get the memory. CXL, that goes away. CXL, I now connect to the memory over a PCI 6E bus, which means I can have any amount of memory with any number of processors. Which means my cost for the hardware to do the database just went down a lot. Because those processors are half or 40% or so the cost of the system. So if I need half as many processors, I just cut my hardware cost by 20%. And I think, as many of you know, when you're doing real-time analytics, you end up spending more on the infrastructure. Even if you're paying StarTree, paying Druid, or Imply, paying someone else, you end up spending a lot more money in the infrastructure than you're paying for the software. This makes the infrastructure a lot cheaper. So we'll see a lot more people using it. Further in the future, we've seen all through the history of computing dedicated acceleration chips. If you're really old like me, you might remember the 387 chip. That was the coprocessor for math that would go next to a 386 chip. By the 486 world, those were gone because all that power was built into the 486 chip and has been ever since. Right now we're seeing GPUs, right? Lots of GPUs to accelerate. GPUs are useless for databases. They're awesome for machine learning. They're awesome for graphics. They're awesome for matrix mathematics. By the end of next year, you won't be able to buy a data center CPU that doesn't come with a bunch of GPUs packaged with it to do machine learning inference. It's just going to get packaged together. Well, there are several companies, most of them are in stealth, that are currently building database acceleration processors. Processors that specifically look at things that databases spend a lot of time doing, like SQL optimization, like ingestion optimization, and putting them into hardware. And if you can do it in hardware, it's always faster and cheaper. So we're going to start seeing those hitting the market 25, 26. I've seen some of the prototypes of these. They're going to improve the performance per CPU by anywhere from 3x to 20x. So what does that really mean? Drive that cost even lower. And drive the adoption even higher. Because the number one reason people don't do real-time analytics today is ignorance, right? They don't know about it, don't know what it can do. I've had that a lot. I've talked to people, yeah, you can query a petabyte in under a second. They say, no effing way, right? Until they've seen these things, and they say, oh, okay, I guess you really can do that. But the number two reason is cost. They say, hey, we'd like to do that, we can't afford it. It's going to drive that cost down. So we're going to start seeing a lot more real-time analytics as the costs are going to go down faster than the data goes up. And then there's cloud maturity. 45% of global infrastructure right now is on public cloud providers. The three largest of them, between them, are about 80% of that market. And then the other 20% is the second and third tier cloud providers, right? Oracle, IBM, DigitalOcean, OVH. We're going to hit 85% in 3 years, 3.5 years. That's probably the roof, because there's always some stuff that doesn't move. So there's going to be some 10 to 15% that will not go under the cloud, but everything else will. By the way, same pattern as mainframes, right? No one's done a new project on mainframes for 20 years, but it's still a $15 billion business. It's not the $100 billion business it was in 2020, but it's still there. It's what happens when you let an IBM guy do a talk. Mainframes have to come into it somehow. Streaming and real-time analytics are the default on the cloud, right? Everyone who builds something on the cloud is doing it with streaming data. And if I've got that Kafka in there, and by the way, we can argue about this, but Kafka has pretty much won the battle to be the streaming technology. There's still a battle for who's going to be the dominant provider of Kafka. But Kafka itself seems to have won that. Pretty much all the there's still Kinesis and some other things, but almost everything out there is either Kafka or Kafka API. So we're seeing that there. Managed services become even more dominant as a delivery model. And that's driven by the cloud and the other things happening. So everything's on the cloud, which means even more things are streaming, which means even more things need real-time analytics. And finally, machine learning. I've got 2 minutes and 10 seconds, so I don't have time to go that deeply into machine learning. Again, I'm really old. I was building machine learning models in 1999 when you could only do that on government supercomputers that cost $100 million. It's cheaper now. Machine learning has three broad categories: unsupervised, supervised, and reinforcement. GANs and LLMs are a subset of reinforcement. I've circled a few of these that are particularly amenable to real-time analytics. So going around, that includes targeted marketing and recommender systems and clustering, big data visualization, identity fraud detection, consumer retention, advertising popularity prediction, and of course the big one down in reinforcement learning, real-time decisions. LLMs, GPT, getting a lot of news right now. I'm not sure they're that relevant to real-time analytics, except they're going to make it easier to gather data. And even though this sounds like a joke right now, they're probably going to be good for data quality. Right now, they're kind of anti-data quality, but they're going to get better, at least for that piece. So AI/ML becomes just another piece of the analytic toolkit. There's a joke that is only funny because it's true, that when you're raising money, you call it AI. When you're recruiting people, you call it machine learning. And when you're implementing, it's a regression. And a certain amount of that actually happens in the real world. But as I said, by 2025, all data center class CPUs have GPUs built in to do machine learning inference. Active GANs, that's a generative adversarial network. So that's when you have two different AI machine learning that fight with each other to create something. That's how the LLMs work. It's also, you see, like one creates a cat picture, the other one says that's a cat, that's not a cat. And surprisingly quickly, it ends up really good at creating cats, as long as the discriminator knew how to identify a cat. So we're seeing this not just for creating pictures. That's, by the way, how things like Midjourney or WALL-E work. Oh, sorry, DALL-E. But that's also being used to do things like build dental bridges at 80% cheaper, because I can automatically say, this is the good bridge. Nope, this is a good bridge. Nope, this is a good bridge. Yep. And then finally, you create it. And as I mentioned, LLMs automate data gathering and, ironically, data quality. So my almost last slide, what do we get in 2030? Exabytes won't be a big deal anymore. Right? We'll be at exabytes and beyond. When I had a job in 1997 at a company that later got acquired by IBM, where one of my roles was to put together the terabyte list of all of the data warehouses in the world in 1997 that had a terabyte of data. Total number, by the way, was 41. Terabyte now is like, the backup hard drive you buy on Amazon to plug into your laptop. Still sub-second response, though, even though I'm hitting at exabytes. Ubiquitous streaming, and one thing, SQL doesn't go away. The optimizers get better, but I'm convinced now that we saw NoSQL kind of failed. I mean, there's a lot of cool databases, but all of them now have a SQL interface. SQL is like the QWERTY keyboard. It might not be the perfect technology, but everybody uses it, so we're kind of stuck with it. And more data. So a zettabyte is 1 billion terabytes. Right? It's 1 million petabytes. Everything humans created from the beginning of writing through roughly the year 2010 was 2 zettabytes. We now create, in 2023, we now create 2 zettabytes about every week. I would argue the average quality of the zettabyte we created last week was less than the average quality of the zettabyte that had like Shakespeare and Homer and all of the stuff in it from the beginning of humankind. A lot of that is medical data. A lot of those things like MRIs and CAT scans. A lot of that is TikTok videos and 38 different resolutions for Frozen 2. But a lot of it isn't. A lot of it is the events. A lot of it is the clickstream. A lot of it is the IoT. A lot of it is all the stuff that's driving real-time analytics. And we're seeing that. And we'll have versions of Druid that support that. Last thing, open source wins. We see this over and over and over again. When there are multiple options in the market, and if it's new and emerging, there's room for proprietary solutions. But over time, open source wins. Look at relational databases. Oracle and SQL Server are still there. But what has the bulk of relational now? It's MySQL and Postgres. And they're the ones that are growing. There are proprietary versions of real-time analytics, but the ones who are part of things like Apache and other open source are going to win. There will not be one winner. The other thing about IT is you don't get monopolies, and if you do, they're short-lived. You get oligopolies. You get 2 or 3 or 4 leaders. Given Druid in its position now, unless the Druid community really messes up, in 2030 it will be one of those leaders. But it won't be the only one. And there will be others. I'm not ready to predict who those others are. Some of them probably don't exist right now. And we'll start by 2030 seeing a lot of that real-time analytics move out of the cloud onto the edge. The hardware is a lot cheaper, more easy to deploy. So we'll see a lot of the real-time analytics not just happening in the centralized cloud, but in telco points of presence or inside vehicles, or maybe in whatever your cell phone is, your smart device. I mean, mine's already smarter than me. It'll be even smarter in 2030. So we'll see where that ends up. So anyone who has a question, come out to the Imply booth or send me an email. So please do send me an email or connect with me on LinkedIn. And a few links here, and you can memorize these or get it in a couple of weeks when it's available. Join the Druid community on druid.apache.org. We have an awesome community, a lot of people active on Slack and elsewhere. If you'd like to know more about how Druid works, download that white paper. If you'd like Building Real-Time Analytics Applications book, which I happen to be the author of, then you can download it for free from there or walk over to a table and get a paper copy. My wife says it's a good book for like a short airplane ride. And if you want to play with Polaris for free, then there's a link to get your free 30-day trial on that. And with that said, thank you very much, and get out there and help change the world. Bye-bye.